hate it until we come to it. No, I never really liked it. I try to like it. Every time I've tried it, I just don't like the unknown, what's under the water. If something came after me, I wouldn't be able to get free quickly, and that lack of control terrifies me. Does anybody here like snorkeling? Never? Do it in a controlled environment. Don't do it on your own. My moral is right. Okay. Oh boy, we got to start back with SOHCAHTOA again. So find the values of the six trig functions. So your sine of theta is opposite over hypotenuse. 5 over what? No. 13. If you know your Pythagorean triples, you'd be better off 5, 12, 13. If not, you only need two sides. You can find the third by the Pythagorean theorem. So 5 over 13. Cosine is adjacent over hypotenuse, 12 over 13. Tangent is opposite over adjacent, and then you have all your reciprocals. Cosecant of theta is 13/5. Secant of theta equals 13/12. Cotangent of theta equals 12/5. This next one's going to be not a Pythagorean triple. Do you know your Pythagorean triples, by the way? Let me tell you what they are. There's an infinite number of them. I'm going to give you the most common. 3, 4, 5. Obviously, your legs are the shorter two. 5, 12, 13. 7, 24, 25. And is it 8, 15, 17, I think? Let me check. I have to check that. 7 squared plus 24 squared. That's 25 squared, so that's good. And then 8 squared plus 15 squared is 289, and that is what 17 squared is. So these are the most common Pythagorean triples, and any multiple of those. So like 6, 8, 10 would count. 9, 12, 15, those all work. Any, similar ratio to those. So do you know by definition what a Pythagorean triple is? So this one here, if you find out b, 1 squared plus b squared equals 3 squared, subtract 1 from both sides, you get b squared equals 8. b equals 2 root 2. That 1, 2 root 2, 3 is not a Pythagorean triple because, why? Aiden? Correct. Pythagorean triples have to be whole numbers. That's what makes them, that's where the term Pythagorean triple got counted. Because any three numbers can make the Pythagorean theorem work. It's just most of the time they're decimals or irrational numbers, like 2 root 2. So I'm going to skip B. We don't need to do the sine, cosine, tangent, and all those. We did it yesterday. We get it. So our special right triangles, and we talked about the 45, 45, 90 one yesterday, where this is x, and this is x root 2. So your ratio of leg to hypotenuse in a 45, 45, 90 is always x root 2. In a 30, 60, 90, the side across from the 30-degree angle is always your baseline. So that's your x. Does anybody know how to get to the other leg from there, or how to get to the hypotenuse from there? Anybody remember that? Olivia? The hypotenuse is 2x, correct? And I suppose as long as you know that the hypotenuse is double the 30-degree side, you could always do your Pythagorean theorem to find out the third if you don't know. Does anybody know and want to save me the time? So x squared plus something squared equals 2x squared. So that's x squared plus something squared equals 4x squared. Subtract x squared from both sides. Something squared equals 3x squared. Square root both sides. And your question mark is root 3x. Or we would say x root 3. So these special right triangles and these ratios that hold true for their side lengths, these are the reasons why we memorize the sine, cosine, and tangent of 30, 60, and 45-degree angles. Because these ratios always hold true. And at the end of the day, that's what the sine is. The sine is the ratio of an angle's opposite side to its hypotenuse. So for the sine of 30, if you go up to the 30-degree angle, your opposite is x, and your hypotenuse is 2x. So x over 2x reduces always to 1/2, which is what you guys should know and remember the sine of 30 degrees to be. Yes? For 45, the opposite x over the hypotenuse x root 2 will reduce to 1 over root 2, but that will rationalize to root 2 over 2. And then the sine of 60, here's your 60-degree angle. Your opposite, x root 3, over your hypotenuse 2x, reduces to root 3 over 2. Now, as far as 0 degrees and 90 degrees, and I'm going to add those, I'm going to say that you can't really use opposite over hypotenuse for those. I mean, I guess you can. Well, I still go back to the unit circle for this. If it's a 0-degree angle, which is really going to make it so the right triangle is non-existent, but if I just made it barely existent, and pretending that this is in the unit circle, essentially how big is the opposite side, which is right here, if this is a 0-degree angle? Zero, right? If it's here, your opposite side is there, but as your angle goes down, that opposite side gets closer and closer to 0, so that when your terminal ray is actually on top of your initial ray, your opposite side truly is 0, and your adjacent side, which is this one, gets closer and closer to being how long? Picture a really big angle. Your opposite versus a really small angle, your opposite. So as your point on your unit circle heads in that direction, your opposite is pretty much 0 and is growing to being how long? 1. And your adjacent is currently about 1 and is shrinking down to be 0 as this point continues in that direction. Do you follow that? If I had an animation, I would do it for you, but I don't. It's the best I can do. So for the sine, and your hypotenuse is always 1 because we're in the unit circle. So for your sine of 0 degrees, your opposite is pretty much 0 over your hypotenuse is 1. And then when you get to the sine of 90, so picture the biggest right triangle you could have, your opposite is 1 over your hypotenuse is 1. Those are definitely harder to visualize, which is why for 0 and 90-degree angles, I would just think about the point at the end of the terminal ray and the fact that that's a 90-degree angle. So your y coordinate is 1, that's your sine value. and your cosine value will be 0, because your cosine value comes from your x-coordinate, versus a 0-degree angle, where the coordinates are 1, 0, your sine of that is 0, and your cosine of that will be 1. Good? Now, do Mrs. Big Eye to help you remember it, because no one's going to go through these ratios every time. That's why we say just memorize it. Did she ever go over with you that this is the same as radical 0 over 2? This is radical 1 over 2, radical 2 over 2, radical 3 over 2, and radical 4 over 2? No. Yes? No? How many people knew that? Maybe. So not that you see radical 0 divided by 2, but that's what it would simplify to. Radical 1 divided by 2 would simplify to that. Radical 2 over 2 is what it is. Radical 3 over 2 is what it is. And radical 4 divided by 2 would give you 1. Does that make sense? Did she go over with you the cosine is exactly the opposite order? So this is radical 0 over 2, radical 1 over 2, radical 2 over 2, radical 3 over 2, and radical 4 over 2, which simplifies to 1. That is probably more likely that she showed you that. That they're just flip-flops of each other. I do know that in geometry, you guys were supposed to know that the sine of 72 equals the cosine of what? Let me give you a picture. Let's pretend this is a 72-degree angle. The sine of 72 is opposite over hypotenuse, right? B over C. The cosine of what would be also B over C? Which angle would I take the cosine of so that it would be B as an adjacent over C as a hypotenuse? Trista. 18, this one here, right? So the adjacent to the 18 is the same as the opposite of the 72. And these two angles in a right triangle always have to add up to 90, always have to be complement. So the sine of 72 is always going to be equivalent to the cosine of 18. Do you remember that from geometry? No? The cosine of 1 degree is going to have to equal the sine of 89. You don't remember that property? Seems to be on every geometry region, so I'm sure way back then you just memorized it and moved on with your life. But anyway, that's what this is. So the sine of theta is going to be the cosine of its complement. Now theta is in radians, so its complement is pi over 2 radians minus it. If you did this in degrees, it would be sine of angle A equals the cosine of 90 degrees minus A. That's the same thing written in radians versus written in degrees. The same is true for tangents and cotangents. And the same is true for secants and cosecants. And then to finish filling out our tangent graph table, tangent just comes from sine divided by cosine. So 0 divided by 1 is 0. A half divided by root 3 over 2. Your 2's essentially cancel, so it's just 1 over root 3. Rationalize as root 3 over 3. root 2 over 2 divided by root 2 over 2. Anything divided by itself is 1. Root 3 over 2 divided by 1 over 2 is just root 3. And 1 divided by 0 is undefined. Good? So now, I'm telling you, you have to memorize this table. You have to know these values. And do you know what Mrs. Rahill does to make sure you memorize your values? There will be days that you will come in and you will pick up a sheet that looks like this. And you will put your name on it, and then Mrs. Rahill will go like this. Number 1. And you have to write down root 3 over 2. And then Mrs. Rahill will do this, and you will have to write down 1/2. And then you will have, Mrs. Rahill will do that, and you will have to write down 1. Do you follow? And Mrs. Rahill will give you all of 3 seconds to write it down. Because if you have it memorized, that means there's no thinking involved. So even though I gave you a nice way to remember this table, root 0 over 2, root 1 over 2, root 2 over 2, that's not something that I expect you to have to think about in the meantime while you're trying to come up with a value, because that's not memorized. That knowledge will help you, if you haven't seen Trig in 2 months, and then all of a sudden Trig shows up on a test somewhere, and you have to remember it. Then if you have something to latch onto that has meaning behind it, that'll help you remember long term. But still in the short term, because we're going to be doing a gazillion of these within any given problem, you have to memorize it. So when we're doing complex problems, and there's a much larger thing that you have to be thinking about, when you're asked for the sine of 30, you don't have to, change your train of thought for a minute to come up with the sine of 30 is 1/2, then go back to the problem and have to reorient yourself oh gosh, where was I in the bigger problem? Because that slows you down, that's why mistakes happen, and that's why you run out of time on a test. So you're going to be doing larger problems where you're going to have to just know sine of 30 is 1/2, throw it in there and carry on so you don't ever lose your train of thought for the bigger problem. That's really the logic. It's the same logic behind why your teachers would throw down a flashcard that said this, and you'd have to write 72 and move on. Does anybody think of 8 groups of 9 and add that up really quickly before they say 72? No, because if you did do that in math, it would take you forever. And you wouldn't be able to ever fully grasp the tougher concepts if you constantly had to take a time out to reconfigure something else like 9 times 8. Do you see it's called fluency. Math fluency. Right? Just like French and Spanish fluency. Connor, why are you shaking your head at me? No. See, did you make flashcards and go through them like you did when you were in 5th grade? So then you're not terrible at memorizing, you're terrible at studying. Okay? Let's take ownership here. Don't tell yourself it's an inborn thing that you're terrible at when you didn't try the right way. Oh wait, by the way, you probably noticed. There are how many? 1, 2, 3, 4, 5, 6, 7, 8. Oh no. 1, 2, 3, 4, 5 times 3. There are 15 flashcards in degrees, and I also have 15 flashcards in radians, so you need to be either or. Got it? In fact, most of PreCalc is in radians, but I know you probably are better at degrees. Now, that to me, and I'm going to be transparent with you. When I see that, I see cosine 30. My mind sees that. So I do process degrees, but it's almost like instantaneous. So I would just put root 3 over 2. So Should you have to stop and convert pi over 6? No. Like, again, that should happen naturally. Anything pi over 6 is 30. Anything pi over 4 is 45. Anything pi over 3 is 60. Okay? So, there you have it. That's what you can expect now that I've officially told you that you have to memorize those. And don't tell me I'm going too fast, because I know how fast 8 times 9 should come to you, which is less than 1 second, and maybe 1 more second to write down the number 72. These you need to know as quickly, which means you need to study them in the same way you studied your flashcard multiplication tables when you were little bitty children. You don't? Oh boy. So this is what I was getting at on the other side. Using those cofunction concepts. The sine of 72 is equivalent to the cosine of, that's kind of funny, isn't it? That I just coincidentally picked 72 on the other side. No, I have not looked at the back of this sheet since last year, so there's no way. And I picked 8 times 9 is 72. If I'm playing the lotto today, 72 is my number. I don't even know if they go up to 72. I'm not a gambler. All right, cosecant of pi over 3. The cofunction of cosecant is secant. Oops, there it is. So in this case, it's the secant of, and again, I will be honest, my mind when I see pi over 3, I see 60. So that complement would be 30, and 30 is pi over 6. If it's in degrees, keep it in degrees. If it's in radians, keep it in radians. Good? What is that? Is that on your paper or just mine? Sorry. That's how it's supposed to be there. All right, a surveyor measured the angle of elevation to the top of a building to be 22. Do you remember angle of elevation? Here's your building. Here's your surveyor. The angle of elevation is the, I like to say, it's the angle with the horizontal with the line of sight. So if he's seeing up to the top of the building, there's his line of sight. This is your angle of elevation, 22. The transit is 5 feet above the ground. Do you know what the transit is? Have you ever seen a construction site that's got like this little thing on a tripod? It's got like a little device at the top? No? That measures literally the angle of elevation. I wish Julia Nunn was here because she would totally know what I'm talking about. You know what I'm talking about? Oh, he does. So that is 5 feet off the ground. So our building is actually going down a little bit further. But with the vision of that device, the horizontal is there and the line of sight is there. So the right triangle we're working in is right here and is only going to give us partially the height of the building, to which we're going to have to add the remaining 5 feet is all. So that is 300 feet from the base of the building. So we are going to look for the building's height. So if we're looking for this, well, part of the building's height to start, are we using sine, cosine, or tangent? Morgan. What'd you say? Cosine. So that cosine of what angle? Yeah. Equals what? Over this. So cosine equals adjacent over opposite? Okay, so you need a new variable. Can I ask you why you're involving the hypotenuse? So we know 22 We're looking for the opposite. We know the adjacent. So which function involves, Morgan, the opposite and the adjacent? Tangent. So you want to use the tangent of 22 equals opposite x over 300. We can't insert the x plus 5 just yet. We have to find this upper part of the height of the building, and then once we have x, we'll just add 5 to it. So this requires the calculator because nobody knows the tangent of 22. What mode should we be in? What is the angle currently in? Is the angle in radians or degrees? Degrees. So if the angle's in degrees, we stay in degrees. So we're just going to multiply both sides by 300 to get x all by itself. So 300 times the tangent of 22, 121 point, we'll just say 2. Feet. That's x. Then we have to add our 5, and so we get 126.2 feet as our final answer for the height of the building. Don't you wonder how they know how tall something is that they can't actually go up and measure with a ruler? You know? Trigonometry. How about a tree? Like if I wanted to know how tall that tree was, I am not going to go get on a ladder and drop a tape measure. Correct? That would be silly. That would be the most literal way I would do it. But the more creative way would be with a tool like a transit. That's probably a transit. What do you hold, like a gun or something? And you probably have to hold some horizontal and make sure it's level, number one. And then you probably have to point the other end up to the top of the object. And then it's probably got a little computer inside that does trigonometry. Because it's not magic, I'm telling you. It's not magic. I would love to get a transit. Can you bring your dad's transit in?
I mean, it's worth $500.
Oh, it is?
Yeah, they're expensive.
Well, I'm sure it is, but it would be a fun thing. Wouldn't it? I'm gonna ask if anyone has a handheld transit we can borrow, or a tripod transit that we can borrow, so that we can take a field trip to the quad out here. I've never used one, so we would all learn together. I think this would be very fun. Does anybody know about engineering? The career of an engineer? Engineering? No? Well, engineering uses a lot of math. Engineers definitely probably know how to use a transit. I'll have to call one of my friends. Huh? It does. But I'm sure in Engineering 101 they all have to do it. All right. A building 21 meters tall casts a shadow 25 meters long. The angle of depression. So the angle of depression, as opposed to the angle of elevation, is from the top looking down. But still, it's the angle created. So if you're up here at the top of the building, your horizontal line of sight is there, and your line of sight down to whatever object is there. The angle between them is right here. That is your angle of depression. It's not the angle that's within the triangle, which confuses people because people just want to put it there. The angle of depression and the angle of elevation have to be the angle between your line of sight and a horizontal. Are you with me? Here's the nice part. The angle of depression from the top looking down is the same as the angle of elevation from the bottom looking up. Who can tell me why from your geometry vocabulary? Yes, Olivia? alternate interior angle. So if you ever are given angle of depression, that is the same as the angle of elevation from the bottom looking up. It can just keep you all within that triangle. So now we need to find that angle. So sine, cosine, or tangent, Mitch? Tangent of x equals 21 over 25. Do you remember on your calculator how to solve these? If you're actually looking for the angle? Inverse tangent, second inverse of 21 over 25. 40-ish degrees. Now, how many radians is that approximately? So if I just change my mode and go to radians, you should know because 1 radian is how many degrees? 57. So this should be less than 1 radian. 0.698. 699. It's been a pleasure. If anyone can inquire about renting a transit or borrowing a transit, I think it would be fun. I'm not one for field trips because I never find good ideas. This would be one.